At Arizona State University, we're bringing world-class education from our globally acclaimed faculty to you. Ranked #1 in innovation for 10 consecutive years and #2 among public universities for employability, ASU isn't just ahead of the curve, it's creating new paths to success. Earn your degree from the nation's most innovative university. Online, that's a degree better. Explore more than 300 undergraduate, graduate, and certificate programs at asuonline.asu.edu.
I earned my degree online at Arizona State University. I chose to get my degree at ASU because I knew that I'd get a quality education, they were recognized for excellence, and that I would be prepared for the workforce upon graduating. To be associated with ASU, both as a student and alum, it makes me extremely proud, and having experienced the program, I know now that I'm set up for success. Learn more at asuonline.asu.edu.
And blast off. We are go for launch on another amazing out of this world episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
I am your host for this lovely evening for me, morning for Fred, and I'm your host, Heidi Campo. And joining us is Professor Fred Watson, astronomer at large. Hey, Fred.
How are you doing, Heidi? It's great to see you after our trepidations yesterday.
Yes. We're coming to you on schedule, but we are a day late.
Yeah.
But the stories are still the same high quality you can expect.
That's right.
We just we had a little bit of troubleshooting to do, but just like the folks over at NASA, failure for getting this episode out was not an option. Mm-hmm. And we put our brains together and figured it out. So
I think you did most of the brain work there, Heidi. I don't think I qualify as being included in that. I just watched the magic happen when you finally appeared on my screen, which was good.
Half of it was luck. I think I just clicked on the right buttons in the right order.
Yeah.
But speaking of luck and a little bit of magic, it looks like our first story this week is some good news. We are not going to be crashing into the Andromeda galaxy.
So we believe. That's right. So the mantra among astronomers for probably decades has been hang on to your hats, folks, because one day we're going to crash into the Andromeda galaxy, probably in about 3.5 billion years. The Andromeda galaxy, just to remind people, is the largest the nearest large galaxy to our own, and it is actually rather bigger than our own galaxy. And so we have measured the speed of what we call the radial velocity, the closing speed between our galaxy and the Andromeda galaxy. That was a measurement that was probably made, getting on for 100 years ago, actually, and maybe more. And the two are closing up. Now, we do get questions occasionally on Space Nuts from people saying, if the universe is expanding, why aren't galaxies all being drawn apart? And, well, they are, but that's on the sort of mega scale. That's on the bigger scale of the universe. When you look at galaxies in the local environment, they are sort of, their motions are dominated by gravitational forces rather than by the expansion of the universe. And that's why in what we call our local group, which is a group of about 24 galaxies, the two biggest are ourselves and Andromeda, they have motions that do not reflect the expansion of the universe because we're looking on too small a scale. It's when you look on the big scale that you see all galaxies whizzing away from us. So, as I said, an easy observation to make. A long, long time ago, astronomers deduced that, yes, the Andromeda galaxy is heading towards us. I can't actually remember the figure. I should have checked it out. It's something like 200, in the region of 200 kilometers per second, which sounds fearsome, except that it's 2.5 million light years away. So there's quite a long time to go, which is why we're talking about 3.5 billion years. So, bringing us a little bit up to date, more than a decade ago now, a European Space Agency spacecraft called Gaia was launched, and Gaia was an astrometry satellite. And what that means is it measured very accurately the positions of stars on the sky, their celestial coordinates, the kind of equivalent of latitude and longitude that we call right ascension and declination, just to give them fancy names. So that spacecraft measured, of course, many, in fact, billions of stars in our galaxy. It's been one of the most productive spacecraft. It's now been switched off. But it also had a look at the Andromeda galaxy. And the reason for that was to see whether there was any possibility that you might pick up what we call a transverse motion. So what you measure, what's been measured for a long time, is the radial velocity. That's the velocity along the line of sight. And yes, Andromeda's coming towards us in that dimension. But there's, of course, also possibly a motion across the line of sight. We call it the transverse motion. And if that was big enough, then you'd get a miss. The Andromeda galaxy would, by the time it reached us, be somewhere else. It wouldn't be along the same line of sight. So that was measured by Gaia. And sure enough, I think what they did was put upper limits on the transverse motion, because it's a very hard thing to do for an object 2.5 million light years away. So the results from the Gaia analysis were that the collision is inevitable. It's going to happen 3.5 billion years ago. Put it in your diary, everybody. However, a new analysis, and this is getting to the point now, by astronomers, if I remember rightly, they're at the University of Helsinki in Finland, a place where we know we've got many Space Nuts listeners, which is great. And what they've done is they've said, okay, that's all fine and dandy. Those Gaia measurements are interesting. They seem to suggest that it is actually coming our way. But what they've said is, wait a minute, we are not the only kids on the block. The Andromeda galaxy and our own are not the only large objects in the local group. There are others, including a galaxy with the marvelous name of M33 in the constellation of Triangulum, another nearby galaxy, not as big as our galaxy or Andromeda, but it's big enough to have its own gravitational forces. It'll have a significant gravitational pull on both ourselves and Andromeda. And they also folded in one of the two Magellanic Clouds. These are small dwarf galaxies which are in orbit around our own galaxy. In fact, they're being swallowed up by our own galaxy. The Large Magellanic Cloud is a galaxy containing probably a few billion stars rather than the few 100 billion that we would get in a big spiral galaxy. So they've taken the gravity of that object into account as well. And when they do, they find that the gravitational forces of those two other galaxies might well pull the two colliding galaxies aside so that they don't collide. They've reported this in actually one of the most prestigious journals, Nature Astronomy. Their article in that journal is called "No Certainty of a Milky Way Andromeda Collision." So what they've done is they've kind of, put the odds of a collision at lower than we thought they were before. Still could be a collision. We won't be here to find out, but they've put the odds lower than before. So maybe we can breathe a sigh of relief.
Yeah, well, I actually pulled up the article, the scientific article itself, and I have it pulled up, and I was just browsing over it. And this really is fantastic, because I do love reading the actual science as it's written by the scientists.
It's the way to do it.
And there is one thing that I'm seeing here that maybe you can clarify for me and our listeners. It looks like they use something, and I'm going to butcher this name. Half of you are going to laugh at me, and the other half of you are going to go, I don't know, sounded right to me. A Fiducial model?
Yeah. Fiducial.
I was not close at all. A fiducial model. So what is the difference between a fiducial model for predicting these orbits or collision courses versus what else might be used?
I'm just looking at the context. Are you reading that from the abstract?
I'm reading that. It's actually down under predicting. It's in the main body of the article under predicting the future.
Yeah. A fiducial model based on the most accurate values available. That's a really interesting term. I haven't heard that term used in this context before. Usually, a fiducial is a a kind of marker. You call it a fiducial mark, which is giving you a 0 point. And maybe that's the context in which that's being used. But great question there, Heidi. I should look through the paper myself in more detail. I did have a quick look at the abstract. I don't usually get down into the detail, but I don't know why they call it a fiducial model. That's quite
I think
interesting.
that's the dirty secret of so many scientists. It's like we are also guilty of reading the abstract, and if it looks interesting, we'll read the methods and everything else. But yeah, it's, unless you're a super nerd, we're not always reading the entire article. For me, if I'm reading science, I read the headline. Okay, is this even in my wheelhouse of something I'm interested in or need to know more about? Then I'll read the abstract. If the abstract catches my attention, then I will actually just jump ahead. I'll skip the intro and background, because if it's something I know about, then I usually already know what they're talking about. And I'll go straight into the methods, and I'll be like, okay, well, what did they do to get their information? Then I'll jump ahead to their results, and I'll see, okay, do their results make sense? And then I'll read their dissemination of those results to see if I agree with their conclusions.
Yeah, I've just been, exactly, you've described the way I look at these things as well. I've just been Googling a fiducial model. and as it says, fiducials are marks or points of reference applied to, well, in this case, images to present a fixed standard of reference. So that was kind of my assumption of what the word means. But a fiducial model gives you obviously a fixed standard of reference to start from, which is tricky when you're talking about colliding galaxies, because which of them's moving? Well, they're both moving. So, where's your reference point? Where is your stationary or standard point?
Yeah, and maybe this could be, and as scientists, we can say, okay, this was published in a prestigious article, so we can assume that the methods were good enough to get published because the process of getting published is already so rigorous. But this could be another point where we go and we're like, hey, is that mathematical model something that you would agree with the results? Is, like you just said, is a fixed model really going to tell us what's moving well, what's not?
Yeah, that's right.
That stuff's kind of interesting.
Let's take a break from the show now to tell you about our sponsor, Saily. Now, if you're planning your next adventure overseas, you can stay connected effortlessly with Saily. It's an eSIM app designed for modern travellers. With Saily, there's no need to swap a physical SIM card in your phone or hunt for local providers. Simply download the app, choose from an affordable array of data plans starting at $1.99 and activate your eSIM instantly. I've done it. I've used it in recent trips and it works seamlessly. Now, whether you're exploring the streets of Tokyo or just relaxing on a beach in Bali, Saily has you covered. In fact, they are available in over 195 countries. But they offer more than just connectivity. Saily has built-in security features like virtual location changes, ad blockers, and web protection, all at no extra cost. And it's compatible with most eSIM-enabled devices, including iPhones, Samsung Galaxy, and Google Pixel. Saily ensures a seamless experience, and I know that's true. Plus, they have 24-hour, 7-day-a-week customer support with access just a tap away. If you're ready to simplify your travel connectivity, visit saily.com/spacenuts and use the code word spacenuts for an exclusive discount. That's saily.com/spacenuts. Saily is your passport to seamless global connectivity. Saily, S-A-I-L-Y, saily.com/spacenuts. Now back to the show.
Roger, you're loud and clear here also.
Space nuts.
But, fiducial models, mathematic algorithms, and flying bananas is my next question. Because a flying banana is the topic of our next article. And this is going to be another thing I need you to define. Because if I'm thinking of a flying banana, I'm thinking that somebody's kid at the grocery store is throwing a fit and they're throwing food. But in this article, we're talking about aura chasers.
Yes. So I'll get to the flying banana in a minute, because that's a kind of nickname. But what I love about this story is it combines two passions of mine. One of which is the Aurora Borealis, the northern lights, which we make regular trips up to the far northern Arctic to watch and take our tour guests up there to be awed by the Aurora. We get southern lights down here in the southern hemisphere as well, the Aurora Australis, Heidi, and there's actually been some quite good sightings recently of the Aurora Australis from southern Australia. We're not anywhere near far enough south to see the aurora overhead as you do from Alaska or far northern Scandinavia, but nevertheless you can see the aurora. So that's one passion, is the aurora. But this is it's a report that comes initially from fellow aurora hunters, and these are people in the United Kingdom, actually in Oxfordshire in England, and they were, basically out on a clear night looking for the northern lights, the Aurora Borealis. But what they saw was this strange blue beam of light sort of slicing through the night sky and apparently moving. And in fact, these are sort of, very high level aurora hunters, because they've got an all sky camera and fixed cameras that have captured this strange blue light moving through the sky. Excuse me. The reason why two things told them that it wasn't an aurora. One is that most aurorae aren't blue. The colours you get typically are green and red, which come from oxygen atoms. You get purples and magenta and a few other colours coming from nitrogen molecules. But a pure blue light is something that, no, you don't actually see. And so what they wondered was, what is this? It's clearly not a natural phenomenon, because it's the wrong colour and it's moving too quickly. So they did some research, and it turns out that what they had seen was a very fat, a wide laser beam pointing upwards that came from the flying banana. And what is the flying banana? It's a railway train. And it's called that because it is yellow. It's very, very yellow indeed, the flying banana. Its technical term is the NMT, the New Measurement Train. And what it does is, at speeds of up to 125 miles per hour, getting on for 200 kilometers an hour in our measure, it runs over the track. Sorry about our little puppy in the background. I don't know whether you can hear him barking, but he's excited about the flying banana as well. This train runs over the track 125 miles an hour with lasers pointing downwards to analyze in real time the state of the track. So it's all about the safety of railway passengers in the UK. And what it's doing is it's analysing things like the separation of the rails, whether something's moved in the foundations of the rails, the sleepers or ties as you call them in the US that hold them together, whether the rails themselves are distorted. They can check the shape of the rails. They can check all sorts of aspects of it at a very high speed. But, and this is the trick, it also checks the overhead electrical wiring, because railways in Britain, many of them, certainly the main lines, are driven by electric traction. So they've got what's called the overhead, the overhead wire, which is picked up, from which the electricity is picked up by the trains. So as I understand it, this laser is also looking upwards to sense what the condition of the overhead wire is, hence the blue light travelling through the landscape. And just before, sorry, I'm not letting you get many words in here, Heidi, but...
No, I'm listening. This is wonderful.
Well, to bring back an experience we had. So back in January this year, some of our listeners know, and I think you know, Marnie and I were doing one of our Aurora Borealis tours up in the far north of the world. We were in northern Norway, Sweden, Iceland, and eventually Greenland, which was enchanting. But that's not why I'm mentioning it. In a place called Abisko, which is in far northern Sweden, one night we were aurora watching, and we saw this vertical green beam of light, which puzzled me completely. It was just pointing upwards. It was apparently stationary. It did not last very long. I had my trusty Aurora camera ready to take photographs, but it had gone before I had a chance to take any. But I'm guessing now that was the same sort of thing, because Abisko is on the main line between the main railway line between Kiruna and Narvik. It was built more than a century ago to carry iron ore from the big mine, which is still operational in Kiruna, to the port in Narvik, where it's exported all over the world, to your country and mine. It's one of the biggest producers of iron ore in the world. And so that railway line has been there for a long time. And my guess is that maybe there is an equivalent in Sweden of the flying banana, which shines a green laser beam up at the overhead wires to see what the condition is. And so I'm putting out to our Scandinavian listeners on Space Nuts, because I know a lot of them are railway buffs as well. Tell us if there is such a thing as a new measurement train in Scandinavia that looks at the overhead catenaries, or the overhead power lines for trains. So we look forward to hearing your answers, folks.
Yeah, and that's such a fun story, and it makes me, because trains are such an incredible feat of engineering that changed the world. I think trains accelerated expansion and growth more than almost anything else. And I'm sure you and most of the listeners know the correlation between rocket ships and trains.
Okay. Tell me what you're thinking of.
Okay. So, now I might be butchering this here, because I think it's something about the rockets, the size of them is a certain size, and that size is determined because of the standard size of. See, what is it? Because I know you probably have it down to the figures.
Well, yeah, so you're absolutely right. It's railway lines and railway tunnels that dictate the size of things. I don't know the exact thing that you're talking about, but it's limited. All sorts of weird things, like the size of the biggest telescope mirror that you can take from one place to another is limited by the size of the track, the railway tunnels that carry them around. It might well be something similar that you're thinking of in terms of rockets.
Mm-hmm. And if you keep going back far enough, the size of the railroad was determined by the average size of two horses side by side. So the joke is two horses' asses is what determines the size of our rockets in space today. And trains, which is just such a, funny little thing to think of, and just, again, amazing feats of engineering. Yeah. And there's nothing new that's ever built. We're always just building and expanding on the prior knowledge we already have. So hopefully our ancestors have done pretty good work.
At Arizona State University, we're bringing world-class education from our globally acclaimed faculty to you. Ranked #1 in innovation for 10 consecutive years, and #2 among public universities for employability. ASU isn't just ahead of the curve. It's creating new paths to success. Earn your degree from the nation's most innovative university. Online, that's a degree better. Explore more than 300 undergraduate, graduate, and certificate programs at asuonline.asu.edu.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And sometimes, things are unsuccessful. We have amazing things. We have things that fall apart. And there was, that's the case of what happened with the Japanese company abandoning their moon mission. So tell us what happened with that, just kind of in a blurb.
Lovely segue there, Heidi. I love your segues from one story to another. And you're right. This is an endeavor which, again, is being carried out with the highest levels of technical knowledge, with the highest enthusiasm, and all the skill that has been learned from, well, more than 50 years now of space travel in terms of robotic spacecraft. As Newton said, standing on the shoulders of giants. I think every one of us is doing that one way or another in the technology that we make use of. So, in fact, some of that technology is just going past my office door at the moment. That's called Grimace. Grimace is our robotic vacuum cleaner. And Grimace makes a lot of noise. So if you hear a whining sound, it's not me, it's our vacuum cleaner.
I named my robotic vacuum Rosie after the Jetsons.
Okay, good. That's great.
Their robotic maid was Rosie.
Yeah, you've got to give them names. Ours is called Grimace because a grimace is the expression on its face. It doesn't have a face, but it just looks as though it's, it's got a very stern expression. Anyway, turning back to the Japanese company iSpace, they have, and as you've said, it doesn't always work. And in this case, this has not worked. What they have done is sent to the moon basically a lunar lander, which indeed had on board a rover, a little rover. The lander, if I remember rightly, is called Resilience. And the rover had a name too, which I can't remember, but it's something similar. So the idea of this company is to be one of the first companies in the world to achieve a soft landing on the moon. And it would certainly have been the first one to have the first private company to have a rover on the moon. Sadly, the mission was not successful. This was last week, as we are recording this episode now. Everything went perfectly well with Resilience until it got close to the lunar surface, and then there was a technical fault that meant that it didn't decelerate quickly enough for it to make a soft landing. So it actually basically had a hard landing on the moon, which we usually call a collision, and that was the end of the mission. They're very enthusiastic, though, about keeping going with their endeavors. Unfortunately, it's their second failure. I think a couple of years ago, they had another mission landing on the moon, which did not make it. It landed, but sort of fell over. It was at the wrong angle, so didn't get any kind of sunlight on its solar panels. I think I'm thinking of the right one there. And by the way, the rover was called Tenacious, built in Luxembourg, in fact, but carried some equipment on board. Sadly, that was never deployed. So, a story that's got good parts to it, because I'm sure they learned a lot from this mission, but not as successful as everybody had hoped.
I always have a little soft spot for the rovers ever since they had the Mars rover sing happy birthday to itself. I've always kind of humanized them ever since that. I don't know why. I'm like, oh, poor rover. Maybe it was Pixar's WALL-E that gave me a soft spot for these robots.
Right. Good old WALL-E.
But, here's another segue for you. Speaking of Mars rovers, the Mars orbiter captured. This is our final story for today, but the NASA Mars orbiter saw some pretty cool sights. You want to tell us a little bit about these volcanoes? Yeah,
that's right. So this is it's a piece of history almost. This is one of the longest running orbiters around Mars. I think it's been in orbit since 2001, or it certainly was launched in 2001, and it is called Mars Odyssey. It's a NASA spacecraft, one of several in orbit around Mars, but this is quite a venerable one. It's been around for a long time, but it's still active, and it's still doing the kind of research that it was basically built to do, looking at the upper atmosphere of Mars and basically, studying the surface. The reason why it's made the headlines this week is because it captured a beautiful view of one of Mars's tall volcanoes. Mars has an area called the Tharsis Rise. It's a high level, or Tharsis Montes, the Tharsis Mountains. It's a high level region which has 4 really prominent volcanoes on it. They are extinct. They probably have not erupted for 3 billion years or so. They're taller than most volcanoes on Earth, 20 kilometers or so. The biggest is Olympus Mons, very famous, the largest mountain in the solar system. But what they've captured with the Odyssey spacecraft is a view of Mars in the early morning. It's in the dawn sky and the dawn landscape, but the surface of Mars is covered with cloud. Now, Mars does have clouds. They're fairly thin clouds because its atmospheric pressure is only 0.6% of the atmospheric pressure on Earth, and there is very little moisture in the atmosphere. There is some. There's enough to form clouds, and they're made of ice, basically, water ice. So there's enough just to form these. But here's this wonderful view, and I encourage people to look at one of the NASA websites. Actually, it's the main NASA website, actually, nasa.gov. If you Google NASA Mars orbiter captures volcano peaking above morning cloud tops, that's exactly what you see. This is Asia Mons, which is one of the other 4 volcanoes in that region, and you can see its crater, its caldera, the summit of the mountain, poking above the low clouds on the surface of Mars. It's an extraordinary view. It's one that we've not seen before, and it was made because the mission scientists managed to turn Mars Odyssey on its side so it could look horizontally at the landscape rather than looking vertically downwards on the surface of Mars.
Yeah, this is a great photo. That's one of those ones that's going to be hanging up in someone's office
Sure.
one day, or a school, in a science building. I mean, that really is a really neat photo, like you said. I mean, what crazy series of stories today, from
Yes,
the things that we've
that's right.
discovered and the technology and everything that humans have done and they're still doing. It's really, and I think that's one reason why, we're space nuts here. I mean, all of us here get so excited about space because I think for the people who are space enthusiasts, it's because there's still so much to do, and so many other fields of and anything. There's so much that's already been explained and discovered. We're not discovering any new laws of physics anymore. That's kind of that. Those are written. But in space, it's wide open, and we're always coming up with new mathematical formulas and feats of engineering and discovery. And we have our highs, we have our lows, but it's so exciting for the people who are still curious and want to know more about the universe we live in.
Isn't it just? And, I guess that curiosity is one of the things that drives the 1 million or so downloads a year that we get of Space Nuts, because we've got people out there who love to hear about this sort of thing, just as we love talking about it. Everything from flying bananas to colliding galaxies. We do everything.
And we just want to, I guess we'll just say thank you to our listeners. Thank you for making this a show worth recording. We really do appreciate you guys. And thank you for letting me come on as your substitute host while Andrew is on holiday. He will be back with you in a few weeks, so don't you worry if you guys are missing him dearly. He will be back. I am just filling in for now. Go ahead, Fred.
Let me just add, forgive me, I think our producer Hugh might well include in this podcast a little recording that Andrew has sent on his progress around the world. So listen on, folks. You might well hear Andrew's voice telling us where he's got to on his round the world trip.
Hi, Heidi. Hi, Fred. Hi, Hugh in the studio. It's Andrew. We've embarked on our round the world trip on the Crown Princess. We left Sydney a couple of days ago and we got out of the Heads, and it was rough as guts. I mean, it was heavy seas. The pilot couldn't even get off the ship, and we had to drop him off at Eden down near the Victoria border yesterday. So, things calmed down a bit after that, but it was a pretty rough old first night. Last night we slept quite well. It was very, very calm. We went through Bass Strait. I was very hopeful that we'd be able to see Aurora Australis. There's been a fair bit of sun activity lately, and I was very hopeful. There'd been a bit about it in the news recently, but unfortunately, we've not seen anything, and in fact, they're not letting us up on the decks at the moment because of the conditions, which are deteriorating again as we approach Spencer Gulf and head to Adelaide. So we'll be dropping off at Adelaide tomorrow and visiting the German town of Hahndorf. Activities on board have been fun. It's a fun crowd, a fun crew. We're having a good time. Yes, I got seasick once. We ordered breakfast and then cancelled it, then ordered again and got 3 breakfasts. So there's, a few glitches here and there, but we're having a great time. I hope all is going well. I'll report in semi-regularly as we do things around the ship and around the world. So for now, I'll see you later and have fun with Space Nuts while I'm away.
So fun. Thank you, Fred. Talk to you next week.
It's a great pleasure, Heidi. Thanks very much.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.